You run Claude, Cursor, and ChatGPT, and you want all of them talking to your GitHub, your database, your Slack. A year ago, that meant a dozen hand-built integrations. Today, it's one open protocol. It's called MCP, and it's quietly become how AI agents actually connect to your tools. So what is it? MCP stands for the Model Context Protocol. Anthropic open-sourced it on November 25th, 2024. It was created by two Anthropic engineers, David Soria Parra and Justin Spahr-Summers, and released as an open standard, not a product. The idea was simple. Give every AI application one common way to reach the data and tools it needs. Here's the problem MCP was built to solve. Say you have 3 AI apps, Claude, Cursor, and ChatGPT, and 3 tools you want them to reach, GitHub, Postgres, and Slack. Before MCP, every app needed its own custom connector to every tool. 3 apps times 3 tools is 9 separate integrations. Add 1 more tool, and you're writing 3 more. This is the M by N explosion. Now put one protocol in the middle. Each app learns to speak MCP once. Each tool exposes itself through MCP once. Suddenly, 3 apps plus 3 tools is just 6 connections, not 9. And it keeps getting better as you scale. 10 apps and 10 tools go from 100 custom integrations down to 20. That's the shift, from multiplying to adding, from M by N to M plus N. The official MCP documentation puts it best. Think of MCP as a USB-C port for AI. Before USB-C, every device had its own proprietary cable and charger. One standard replaced the whole drawer of adapters. MCP does the same thing for AI applications. One standard port, and any compliant tool just plugs in. MCP has a simple shape, just 3 roles: the host, the client, and the server. Get these 3 straight, and the whole protocol clicks into place. The host is the app you actually use. The client is a connector living inside that app. And the server is the program that exposes your tools and data. Let's take them one at a time. Start with the host. That's the AI application you open and interact with. Claude Desktop, a coding editor like Cursor, or a custom agent you built. The host is in charge. It manages your permissions, it decides which servers to connect to, and it asks for your approval before anything sensitive happens. Think of it as the cockpit. You sit here. Inside the host live the clients. A client is a small connector, and here's the key rule. Each client holds exactly one dedicated connection to exactly one server. 2 servers means 2 clients, running side by side. The client handles the plumbing, opening the session, negotiating the protocol, passing messages back and forth, so the host can stay focused on you and your request. Then there's the server. A server is a lightweight program that exposes a specific capability. Your file system, a GitHub account, a Postgres database, a Slack workspace. It can run locally on your machine or remotely in the cloud. Crucially, the server never talks to the AI model directly. It only talks to its client. And anyone can build one, which is why there are already thousands. So a server exposes capabilities, but what kind? MCP defines exactly 3, called primitives: tools, resources, and prompts. The clever part is who controls each one. Tools are controlled by the model. Resources are controlled by the application. And prompts are controlled by you, the user. 3 primitives, 3 different owners. That separation is what keeps an agent both capable and safe. Start with tools, the ones the model controls. A tool is just a function the AI can choose to call on its own, to actually do something. Here's a simple one. Write file, which takes a path and some content and writes it to disk. When the model decides it needs to save a file, it calls this tool. Tools have side effects. They change the world, so the host gates them behind your approval. The other 2 primitives are quieter, but just as important. Resources are application controlled. They're read-only data the app pulls in and feeds to the model as context, the contents of a file, a database schema, a log. Prompts are user-controlled. They're reusable templates you deliberately pick, like a code review workflow. Notice the pattern. The model acts through tools, the app supplies resources, and you trigger prompts. How do the client and server actually talk? 2 transports. If the server runs locally on your machine, MCP communicates over standard input and output. The host simply launches the server as a subprocess. If the server runs remotely in the cloud, MCP uses a mechanism called streamable HTTP. Same protocol either way, so a tool behaves the same, whether it's local or remote. And this is genuinely all it takes to add a server. Here's a real config file for Claude Desktop. Under the MCP servers block, you name one, file system. You tell it the command to run, and which folders it's allowed to touch. Save the file, restart the app, and Claude can now read and write in those directories. No custom code, just a few lines of JSON. And people have built a lot of servers. Because the protocol is open and a server is small, the ecosystem exploded. There are now thousands of them, official and community-made, for everything from GitHub and Google Drive to Postgres and Slack. Public registries let you browse and install them in a click. Build one server, and every MCP-compatible app can suddenly use it. Here's how far it spread. It started at Anthropic, in Claude Desktop, and Claude Code. Then the coding editors came aboard. Cursor and Visual Studio Code can both connect servers. And then the other big labs. OpenAI added MCP support to ChatGPT through its developer mode. Google's Gemini command line tool connects MCP servers as well. A protocol from one company has become common ground across the industry. Now the honest part, because this power cuts both ways. First, prompt injection. A malicious server can bury instructions inside the data it returns, tricking your model into doing something you never asked. Second, by default there is no sandbox. A local server runs with your full permissions. It can read your secrets and run shell commands. So running an untrusted third-party server is like running a random script off the internet. And remote authentication is still maturing. Treat new servers like new software. Verify before you trust. One last piece of honesty. You don't always need MCP. If you're writing a one-off script or wiring up a single hard-coded integration between two systems you control, just do that. It's simpler. MCP earns its keep when the numbers grow, when many tools need to meet many apps, and you want to build each connection once instead of over and over. That's the whole point. Addition, not multiplication. So here's the architect's lens on MCP. 1. It's a standard that turns M by N custom integrations into M plus N. You build each connection once, and everything compatible can use it. 2. Remember 3 and 3. 3 roles, host, client, and server. 3 primitives, tools, resources, and prompts. 3. The risk is real too. A server runs with your permissions, so verify it before you connect. If breakdowns like this help you build, consider subscribing. Thanks for watching.